Strongly consistent operations mean that when you perform an operation in cloud storage and you receive a success response, the object is immediately available for download and metadata operations from any location where Google offers service. The following operations in Google Cloud Storage are strongly consistent: read after write, read after metadata update, read after delete, bucket listing, object listing, and granting access to resources. Eventually consistent operations mean that when you perform an operation, it may take some time for the operations to take effect. The following operations are eventually consistent: revoking access from objects and accessing publicly readable cached objects. Revoking access can take up to a minute for changes to take effect, so operations won't be consistent until the revocation has taken place. Publicly readable cached objects are eventually consistent if the object is in the cache when it is updated or deleted. When the object in the cache is updated or deleted, the operation doesn't take effect until its cache lifetime expires. Depending on the operation you are performing and your application requirements, you can access Google Cloud Storage through 3 request endpoints or URIs. Using the XML API, you can use the 2 listed URIs, and using the JSON API, you can use the listed API. These URIs support Secure Sockets Layer (SSL) encryption, so you can use either HTTP or HTTPS. If you authenticate to the Google Cloud Storage API using OAuth 2.0, you should use HTTPS. A CNAME redirect is a special DNS record that lets you use a URI from your own domain to access a resource, bucket, and object in Google Cloud Storage without revealing the Google Cloud Storage URI. For example, if you've published the following: travel-maps.example.com, cname c.storage.googleapis.com, you could access the object at http://travel-maps.example.com/parish.jpg. You can also access resources using authenticated browser downloads, which let you download data through your browser if you are signed into your Google account and have been granted permission to read the data. Authenticated browser downloads use cookie-based Google account authentication in conjunction with Google account-based ACLs. To download an object using cookie-based authentication, you must use the following URI: https://storage.cloud.google.com/the bucket name/the object name. You can modify the content-based load balancing configuration to route requests for static content to a cloud storage bucket. Requests to URI paths that begin with /static are sent to your storage bucket, and all other requests are sent to your virtual machine instances. You will create a backend bucket for your cloud storage bucket, modify the webmap URI map, and fetch resources using either of the listed URIs. You can compose up to 32 existing objects into a new object without transferring additional object data. Object composition can be used for uploading an object in parallel. Simply divide your data into multiple chunks, upload each chunk to a distinct object in parallel, compose your final object, and delete any temporary objects. In parallel uploads, you divide an object into multiple pieces, upload the pieces to a temporary location simultaneously, and compose the original object from these temporary pieces. Some use cases include fully using your available bandwidth by dividing your data into chunks and uploading them separately, and copying many files in parallel with a single command in big data scenarios. Truncated exponential backoff is a standard error handling strategy for network applications in which a client periodically retries a failed request with increasing delays between requests. Clients should use truncated exponential backoff for all requests to Google Cloud Storage that return HTTP 500-429 response codes, including uploads and downloads of data or metadata. Understanding how truncated exponential backoff works is important if you are building client applications that use the Google Cloud Storage XML API or JSON API directly, accessing Google Cloud Storage through a client library, or using the gsutil command line tool. The Google Cloud Platform Console sends requests to Google Cloud Storage on your behalf and will handle any necessary backoff. The example shows a backoff implementation for the Python retry library when you retry distributed services and other remote endpoints.